Hi everyone, welcome to the final stop of the Elora trip. You can see now that we're at the base of the gorge. And there are a few things that I want to note here just about how the gorge was formed and some of the different kinds of time periods that we need to think through to understand how this particular landform came to be. So a gorge is also known as a canyon, and it's a deep cut between two cliffs, and it's primarily the result of fluvial erosion, so water cutting into the rock and creating the gorge feature here. One of the things that's distinctive about Elora is that there is no waterfall. Waterfalls are very commonly found within gorge features, but there is not one at Elora, so that's something interesting to kind of note here. There are at least two different major time periods that we need to take into account when understanding Elora. And the first is the rock type that's present. The rock type in Elora is a kind of limestone known as dolostone, and it was formed around 410 million years ago. And at this point in time, this part of southern Ontario would have actually been south of the equator. And these rocks would have developed at the floor of a warm tropical sea. So the rock is actually an accumulation of fossils, sea creatures, and coral, very, 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 very densely packed together over kind of millions of years according to pressure. So, as noted, this rock type is a kind of limestone that would have formed around 410 million years ago and would have moved to where it was now very, very slowly according to the shifting of tectonic plates since then. There is more information about this in the slide deck for this week, so take a look at the Field Trip 2 deck that is in last week's content and this week's content. There are some useful figures that are valuable to take a look at, and they'll give you some more visual information about where Elora was around the formation of these rock types around 410 million years ago. And it does some good work to kind of contextualize that geological period of time alongside other kind of later and earlier formations. So do take a look at the slide deck online to see some maps and other visual representations of kind of what I'm describing, only very briefly. So I mentioned that there are two major time periods that are important for understanding Elora. The first around 410 million years ago for understanding the rock type, but just understanding the rock type doesn't really explain how this gorge is here, right? The gorge is a cutting into of the rock by some phenomenon, and so we also need to think about how this kind of crevice or schism came to be in this particular time and place, which is only partially explained by the rock type that formed 410 million years ago. The other kind of major time period for understanding why this gorge is in this particular place are conditions that formed at the end of the last ice age, so 15,000 or 16,000 years ago. The Earth went through a significant warming around this period of time, and this was also around the time when some of the major glaciers in this area were retreating. So there were three major lobes or glaciers, all retreating kind of around this same point in southwest Ontario, around Waterloo, around Elora. And the receding glaciers associated with the warming coming off the last ice age caused ice melt and also water to kind of flow through this time, through this area at this particular time. So for the first time in a long time, water would have been able to flow over these rocks and over the kind of soft dolostone limestone. It's important to note that glaciation specifically is not the reason why the gorge has formed, but the water melt kind of as a result of the retreating glaciers. So it's not glaciers themselves that caused this, it's fluvial movements, so movements of water, not movements of ice. So that's an important distinction to make, that glaciers and glaciation weren't the kind of direct cause of Elora Gorge, but kind of contributed to the formation of the gorge because they were retreating and they were also melting slowly. So things like snow melt and ice melt and water essentially flowing through the rocks and causing erosion are what caused the gorge to be in this particular place in time. So water finding small weaknesses in the rock, the soft rock, over the past 16,000 years, finding those weaknesses, exploiting them, weathering through them, and eventually creating this particular kind of way of the water cutting through the rock. So as water melted in the summers, water rushed southward, it began to cut channels through more exposed bedrock. When ice disappeared altogether, streams continued to flow through some of these cut rock channels. And this weathering would have occurred in a variety of ways. Some of it would have been freeze-thaw weathering. Some of it would have been the water picking up small amounts of silt and the silt rubbing against the rock to cut into the rock that way. Weathering occurs in a variety of ways, but the kind of the takeaway is that since this period of time, since around 15,000 years ago, due to a warming climate, water would have found weaknesses in the rock and cut channels into the more exposed bedrock. So those are the two kind of most elementary ways of thinking about how Elora Gorge came to be. These two different time periods, 410 million years ago, and then 15 to 16,000 years ago, as a result of rock type and water being able to cut through that bedrock for the first time. We can also think about a number of other much more recent things that will affect the typology and formation of Elora Gorge in this time and place. There are lots and lots of things like minor and major storm events affecting the cliff profile, freezing and thawing of rainwater, rock falls potentially, vegetation growing into the cliff, sometimes causing erosion, sometimes actually binding the cliff together with their roots. Flood events, major floods occurred here in 1954 and 1974. Floods may be the reason for the presence of some large boulders in the gorge that you can kind of see on the video for this stop, and things like human intervention in the area too. So as much as there are kind of two major time periods that I've identified for understanding how Elora Gorge has formed, there are lots and lots of other larger and smaller micro and macro events that will kind of affect the cliff profile in a more local sense. So definitely think about those other kinds of things too. Even the way, the sunlight hits the rock, things like wind-based weathering, right? All of these things are kind of happening all the time and will affect the cliff profile, the gorge profile in a variety of ways. That's all I want to say at this stop. Do take a look at the PowerPoint slide online. Those will help you to think through some of these issues in a more visual way. There are some diagrams of things like the cliff profile and cliff ecologies, diagrams of the retreating glaciers, and the different geological periods that you'll need to kind of use to understand the formation of the gorge in this particular time and place. If you have further questions, please let me know. Do take a look as well at the assignment description, and that will help you to complete your field trip 2 report. Thanks so much. That's all for this stop.